So we're going to talk about functions as rules, but before that we should probably review what it means to be a function. So a function is really just an equation. Actually, it's not even necessarily an equation. It's a relationship. We call it a relation between two sets of values. So one, the input set, we call the domain. And the output set, we call the range. Okay, lots of new words there. The important ones are a relation. So a function is a relation or relationship between two sets, the domain and the range. And you deal with these relations all the time in the real world. You just don't necessarily know that you're dealing with a function. You and a group of friends go to a movie, and the total cost of all the tickets is a relationship between the number of people that go and the price of the tickets. That's a function. So we also want to be considerate of how the domain and range sets relate to each other. So I'm going to call them inputs and outputs. And we have a way of diagramming this. These are two little holes in the ground you can throw things in, I guess. We're going to call this the input set and this the output set. So if I put into a function the number 1 and it gives me out the number 2, we're good to go, because there's a special rule that says each input maps or points to, let's say points to, exactly one output. Now, that's how we always say it, but it should be said that if there's any output. So it's possible to have an input that doesn't point anywhere, but if there is an output, then there's exactly one output. As soon as you have something that has more than one output, it still may be a perfectly fine relation, it's just not a function. And so this really is the most important thing I've said so far in defining functions. That functions have to have one input points to one output. So if I had 3 other inputs here, if 3 points to 6, I'm still good to go. Now watch, this can get tricky. If 6 points to 6, I'm still good to go. Because even though 3 and 6 both point to the same output, 3 only points to 1 and 6 only points to 1. All we care about is that functions or inputs point to exactly one object, just one of them. So whatever the input is, it points to exactly 1. So we're perfectly fine with 3 and 6 both pointing to 6. But here's what's not allowed to happen. You're not ever allowed to have 6 point to 6 and 4. So 6, my input, now points to 6 and points to 4. That's not okay. Okay? So it's not a function if that happens. Not this. Okay, let's move on to some real examples that might help to make this clearer. So, my friend Miguel got a job, and every hour he works, he makes an additional amount of money. And if I were to make a table to show how much money Miguel makes, this is what the table would look like. His input would be the number of hours he works, right? So his input is how many hours has he worked. And the output of the table is how many dollars did he earn. So he goes to work and he works 2 hours and his boss gives him $14. Okay? He works 5 hours the next day and his boss gives him $35. The next day he works 7 hours and his boss gives him $49. And the next day he works 8 hours and he gets $56 for the whole day. So this is a relation. We can look at it as a function. It's a relation. It's a relationship between the number of hours Miguel works and the number of dollars he makes. But is it a function? Well, let's make a table, or let's make one of these diagrams. I don't really like drawing these. Sorry, I'm not very good at it. But, oh, that one's pretty good. Okay, so input, output. So we have 2 points to 5. Oops, sorry, 2 points to 14. 5, input value 5 points to 35. 7 points to 49. And 8 points to 56. This is a totally acceptable function. We can call it a function because every element in the input, or every element in the domain, right? Input is the domain, points to exactly one input in the range. So 2 only points to 14, 5 only points to 35, 7 only points to 49, 8 only points to 56. This is definitely a function, and we're going to learn a whole bunch of math that applies only to functions. So let's do another one, only this time instead of telling a story and breaking down Miguel's pay over time, let's actually start with an equation. Let's start with y equals x plus 4. So this is just an equation at this point. We don't know if it's a function or not. Let's determine if it is. Okay, let's determine if it is, and I'm going to tell you that the input set is 0, 2, 5, 7, and 8. This is the domain. Because that's the set, that's the input set. This is another word we use for input set is the domain is the independent variable. Right? It's the one we get to pick from. We're free to choose a number. So I can choose 5, or I can choose 2, or I can choose 8, 7, 0. I can choose these numbers in any order. So I'm independent. I'm free to choose them. When I put them in the equation and I get an answer out, that's going to be called the dependent variable because it depends on what I choose to put in before I get something out. So let's go ahead and put our table together and look at what I mean when I say input and output. So our domain or input variable is the one that's part of the equation, right? See how this has all kinds of stuff going on? We're going to put a number in here, we're going to process it with all this other stuff, and then we're going to see what y equals. So x is our independent variable in this case, and y is our dependent variable. Let me write that down. That's y. All right, so let's go ahead and calculate this out. Well, if I put in, now I'm going to change this table a little bit because when I'm working with an equation, I don't really like this table because I have to do all kinds of scratch work all over here. So I have another table I prefer to use, and I'm going to show it to you right now. I'm going to put my table vertically, so I have x, and then I'm going to put my equation, y equals x plus 4, here in the middle, and then at the end I'm going to put a place for me to write my y down. Okay, so now let's put this over here because y is my dependent variable. And I'm going to choose to put 5 in. I'm going to choose 5 for x. So in the x column I'm going to put a 5. So y equals 5 instead of x plus 4. So y equals 9. And I'm going to put 9 over here. This time I'm going to choose 0. Y equals 0 plus 4. So y equals 4. So now instead of having to work on scratch work over here, I can actually put all my work right here and I can see exactly what happened. This time I'm going to choose 8. So y equals 8 plus 4, and that's 12. 7 I'm going to choose this time. Y equals 7 plus 4, and that's 11. And do I have them all? I don't. Let's see, I need a 2. So y equals 2 plus 4, which equals 6. So now I can put together my input-output relationship, right? I'm going to use these little bubbles. Probably need a bigger one than this. And if my domain is 0, 2, 5, 7, 8, I'm going to map each of these numbers. Map is the same thing as point to. I'm going to map each of these numbers over to my output. So my domain and my range. So 0 pointed to 4. Okay, I'm good with that. 2 pointed to 6. Okay, and by pointed to, I'm saying I run it through the function, or excuse me, through the equation, and I see what I get. So 5, if I plug in 5, it points to 9, 7 points to 11, and 8 points to 12. And I can say, because every single element in my domain only points to one element in my range, I can say that this is a function. It's also an equation. We don't care about that as much, but we also know it's a special equation that is a function. It has an input variable, which is independent. It has an output variable, which is dependent, and each input points to exactly one output. So now we're ready to work with our title, Functions as Rules. What we want to do is, I started with a rule. I didn't tell you that that's what we were dealing with, but the equation that you use to figure out a function, this equation is called the rule. So we want to actually get a bit of information, get a table, and then from the table we want to find the rule. We want to write a rule from a table. Okay, so let's do that. I'm going to give us a table, and this time I can go horizontal because I'm not going to be calculating the equation. I'm going to be discovering the equation. So for this example, I have my input. I'm going to call this x. I'm going to define x as my input and my output y. My inputs or my domain are 1, 2, 4, 7, 9. And then my outputs are 0, 1, 3, 6, 8. So the first thing we have to do before we try to make a rule is decide that it's in fact a function, because if it's not a function, finding a rule is going to be of no value to us anyway, because we want to write rules for functions. So the number 1 points to 0 and nowhere else. There's no other 1 here that would point to something else. 2 points to 1, 4 points to 3, 7 points to 6, and 9 points to 8. So this is a function. If I had another column here that had a 2 again with a 3, you can see I have 2. This would be the same 2 on a number line. If I were to put this on a number line, if 2 is here for the first one, 2 is here for the second one as well. So if I repeated a number in the domain and got a different output for the range, then I wouldn't have a function. Luckily, that's not what happened, so I can move on. So I want to find a function with respect to x, right? A function in y with respect to x, which means I want a y equals, I'm going to do some kind of a formula here where there's an x in it somewhere. So I want to know what are the numbers that I'd have to put together in order to give me 0 if I put in 1 for x, 1 if I put in 2 for x, 3 if I put in 4 for x, 6 if I put in 7, and 8 if I put in 9. And look at what I have. My output is the same thing as x minus 1, right? 9 minus 1 is 8. 7 minus 1 is 6. 4 minus 1 is 3. 2 minus 1 is 1. And 1 minus 1 is 0. Right? So x minus 1 would be the rule for this function. Let's check it out. Let's just work in reverse and see. So I've got x. I think the equation is y equals x minus 1 y. So I'm going to put in 1 for x. So y equals 1 minus 1, which equals 0. Oh, that one worked. I'm going to put in a 2 for x. Y equals 2 minus 1, which equals 1. That one worked. Put in a 4 for x. Y equals 4 minus 1, which equals 3. That's true. 7. Y equals 7 minus 1. Gives me 6. That's exactly what I got here. And for 9, y equals 9 minus 1, which equals 8. And that's exactly what I got here. So I know that the rule for this table of input and output values is y equals x minus 1.